Okay, here we go. Well, not yet. First, we need to have a little chat. Take a deep breath. We have done a lot of work in this class so far. If you are feeling like there's things that you don't quite understand, don't forget you can go back and you can fix it. It's not too late. Yes, it's going to take some extra time and extra effort on your part, and I know that's probably the brick wall that you've come to in the first place. You can do it. You've made it this far into high school and into this class. So you are more than capable of doing this work. The next section of stuff is not specifically anything new. It's all the same stuff. We're still talking about forces. We're still talking about friction. We're still talking about acceleration and displacement and work and energy and impulse. We're still talking about all of that stuff. After 4.1, we're going to go deeper into those topics and dealing with them in 2 dimensions. So far we've been only working with 1 dimension. We've had balls falling straight down, or we've had boxes being pushed along. Now we're going to deal with things that are happening at an angle. And when they're happening at an angle, they're moving this way and this way at the same exact time. So it's important to have a good, solid foundation. If you don't have that foundation for the 1 dimension, give yourself 2 videos a day to go back and catch up. It will help you. I'm going to make these videos and assume that you know how to handle 1-dimensional problems up to this point. So if it seems like I'm going fast or you get stuck, maybe you get stuck on dealing with velocity in 2 dimensions. Then go back and watch a velocity video. Okay, so those things are always there for you. The whole idea of this is for you to fully understand this material. Make sure you're asking a lot of questions in class. I know I don't stress it enough, but hopefully by this point in the year you feel comfortable enough to where you can ask me for help or ask each other for help. If the person sitting next to you doesn't know, the person sitting across from you may know. Talk to each other. Help each other. Every person that you help is going to make you that much stronger in that specific area. It's not true for my class only. It's true for math, history, anything like that. As you teach back to somebody, you get better. Okay. So, with that, let's move on and get into some vocabulary and look at our essential question, which is how do we use vectors to model quantities that have direction? We need to be able to identify a quantity as either a vector or scalar. We can do that. Be able to represent a vector numerically as magnitude and direction, or as components, or graphically, which is just a drawn arrow. We need to be able to change magnitude and direction into components, and vice versa. So change magnitude and direction into components, and components into magnitude and direction. We need to be able to perform vector operations, add and subtract vectors, multiply a vector by a scalar, and give physical meaning to these operations. Our vocabulary, magnitude, just means the number or amount of some quantity. In physics, magnitude is the same words as absolute value in math. There it is. There it is. It's up there. Absolute value is just magnitude. Scalar is a quantity that has only magnitude. So we're only looking at how big or how much, but no direction. Vector has both magnitude and direction. Oh yeah. Components, 2 numbers. One is called a horizontal component, and one is called a vertical component. that describes how far right or left a vector goes and how far up or down a vector goes. So if I give you a vector that's at an angle, like this, then I have this horizontal component, this piece along the bottom, and then I have this vertical component, how high up it goes. They're both happening at the same time. Components are just pieces. So if we're resolving something into its components, we're breaking it apart into its pieces. So what is a vector? A vector is a quantity that has both magnitude and direction. Magnitude is an amount, direction is where the quantity points. In physics, we have studied 4 vector quantities: displacement, velocity, acceleration, force. Momentum. That's not 4, that's 5. What is a scalar? Scalar is a quantity that has only magnitude but no direction. Examples of scalar quantities include temperature, time, distance, speed, mass, energy. How do we represent a vector? Energy is a scalar. I don't know if you caught that or if I went too fast. Note that each vector has a name, the letter next to it. So this would be vector A. Vector names are the same as any other variable. It's just some random letter. It doesn't mean anything specifically. But they have the arrow over them to indicate that it's a vector. Notice this little arrow. Vector A, vector B, vector C, vector D. Vectors A and D have the same magnitude and the same direction. So those two vectors are equal. Terrifying, right? It's not that bad. We'll deal with it in the next video.